Hello everyone, welcome back to our new chapter relation and function. So this is our chapter relation and function, which is a book of NCERT class 11th maths. So now we are here with introduction. So in introduction we will know the what is the actual outcome of this chapter. Okay, so relation and function, right? So in this particular video we are only going to study about the Cartesian product of sets. Okay, so we are not talking about relation and function right now. Just to give you the hint what is relation and function, let me just tell you that relation is any kind of relation. For example, in our real life we have relations like father and son, right? Father and daughter, right? Teacher and student. So there are so many relations in our real life. Same as in mathematics, if you see, there are so many relations between different concept of mathematics. uh, for example, just let me write it here. For example, the relation between two numbers. Okay, so 2 is less than 4, this is also a relation, right? So this type of so many relations are there, and the study of all these relation, okay, is included in this chapter relation and function. So relation as the name is here, relation. So we can just imagine that what is relation in our real life: a father son, a father daughter, teacher student. So same like in mathematics, when we see about what is the relation between two numbers and two concepts, so this is covered in this chapter called relation. And second one is function. So function is also a relation, but it is a special type of relation. Okay, so now let's back to our topic, Cartesian product of sets. Okay, so what does it means? For example, I have this iPhone, blue color. Okay, so this is blue color iPhone, and this is a light blue or white, something like that, I don't know the exact color. So we have two iPhones, the first and the second one. Okay, and we have also two cover. Look at here. Okay, this is pink type and this is a gray type cover. So if someone is asking that if you have two iPhone and two covers, so how many different style you can make with these two phone and two covers? what i mean what I mean is, if we will put this cover on this phone, it will be style number 1. If we will put this cover on this color, it will be style 2. And if we put this color on the different color of iPhone, then it will be style number 3. And if we will put this pink type cover on this iPhone, then it will be style 4. So if we have two iPhone and we have two cover, so how many style we have made here is 4. Okay, it means we have to multiply, right? So Cartesian product of set is, we have to do the multiplication only. Overall we have to do multiplication. Okay, here is the definition given to non-empty set. This is important. Okay, non-empty means it should not be empty set. Okay, or it should not be a empty set. Okay, given two non-empty sets P and Q, the Cartesian product P into Q, I told you that we have to do multiplication, is the set of all ordered pair. Okay, and this is also important. Let me just highlight the important one with a different color, red. It should be a non-empty set, right? So Cartesian product P and Q is a set of all ordered pair. Okay, this is also important of element from P and Q. So let's understand what does mean of this non-empty. So non-empty, non-empty means it should not be a empty set, right? And ordered pair, ordered, ordered pairs means ordered pair means, for example, we have a set 1, 2 and 3, and we have another set 5 and oh my god, Mr. Dogges is angry, I think. Okay, so if we will do the multiplication between these two, the order pair will be first we will multiply all these elements with, we will take pair with 5, so it will be like 1 comma 5. Okay, then we will have 2 comma 5, then 3 comma 5, right? Now 5 is we have taken all the pair with 1 2 3 with 5. Now we will take all the pair of 1 2 3 with 7, so it will be like 1 comma 7, 2 comma 7 in ordered pair, okay, and 3 comma 7, right? So the meaning of ordered pair is we have to follow order and we have to make a pair of two elements from P and Q. We will take one element from P, then one element from Q, then we will take another one element from P and we will do with the same element of Q. Then once we will complete with all the element of P, then we will move to the second element of Q if there is any, right? So now another thing is we have given A equal to 1 comma 2, right? This is a pair of two numbers, and B equal to 2 comma A. It's asking is A equal to B? We have to find out. Okay, so let me just close the door because this dog is making so many noise. Hopefully the noise will be controlled now. Okay, so A comma A equal to 1 comma 2. So suppose this is X and this is Y, right? So X, for the X1 and Y2, we will get this coordinate. Okay, this is the coordinate for 1 comma 2. Now B equal to 2 comma 1, so B is 2 and Y is 1. So just tell me that is these two coordinates are same or different? So absolutely this is different. This is here and this is here. It means A is not equal to B. It means if we say 2 comma 1 and 1 comma 2, then these two are the different thing. These are the two different coordinates, right? So this is very important, so I thought I should tell you this. Now we have some important points. Let me just make star. I don't know how to draw it. Something like that maybe, or we can draw it like this. Yeah, this is the good one. So two ordered pair, right? Two ordered paired are equal, means two ordered pair will be equal if and only if and only if the corresponding first element are equal and the second element are also equal. It means if someone is saying A equal to B, it means the element of A will be 1 and 2 if then the first element of second order pair, here you see if and only if the corresponding first element are equal. So first element, if first element are equal, then 1 will be here and the second element are also equal, so comma 2, then we can say two order pair. This is also order pair, this is also order pair, So two order pair are equal if and only if the corresponding first element are equal and the second elements are also equal. Hope you have understand this, right? Now the second thing, if three sorry if there are p element in A and q element in B, then there will be pq elements in A into B. Example, if number of A equal to P and number of B equal to Q, then number of A into B equal to, okay, so let's forget the definition. Let me just make you understand. Undo add stickers, no, we don't have to. Okay, so let me just quickly clear this, right? So it's saying, the second one is saying that if there are p and q element, means for example, if set A have a 3 element and set B have a 2 elements, then if we will do the multiplication, we will take the all the ordered pair A into B, then it will be the 3 into 2. Let's prove it. Means 3 into 2 means we can say it will be there will be the 6 ordered pair. Suppose we have A equal to 1, 2, 3, right? We have 3 elements as per this, and B equal to 5, B equal to 5 comma 7, right? So here what we see, if we will take the ordered pair of both two sets, then there will be 6 order pair. Let's see, let's take order pair of 1 2 3 with 5. Okay, so A into B equal to, there will be order pair 1 comma 5, then 2 comma 5, then 3 comma 5, right? Now we will take order pair of all 1 2 3 with 7. So 1 comma 7, 2 comma 7, now 3 comma 7. So we have 1 2 3 4 5 and 6. We have total 6 order pairs, and here also you can see we have calculated that we have 6 order pair. Now let's read this definition again, and hopefully now you can understand that what it's saying, right? Saying if there are p element in A, so in A we have 3 elements, right? We have 3 elements and q elements in B. So in B we have q elements, means something, p and q are variable, we can put any value there. Then there will be p into q elements. So p into q elements, p into q equal to 6, right? There will be p into q elements in A into B. So when we will do A into B, here when we will do A into B, then there will be p into q elements, means 1 2 3 4 5 6 elements, right? Okay, let's erase this and see what is point number 3. Okay, so now if A and B are non-empty set, means A and B are not empty. Suppose A equal to something 1 comma 2 3, and B equal to, I have not closed this because I don't know how much we have to write here. And if we have 5 9, so if A and B are non-empty set, so this is not empty, we have written some elements here, and either A or B is an infinite set, either A or B. Suppose this is a set of all natural number, okay, so it will be infinite. Okay, so either this or this is infinite, or B is infinite set, then so is A into B. So is A into B means then the product of A into B will be also infinite, right? We will write 1 comma 2 we will write pairs like 1 comma 5, then 2 comma 5, then 3 comma 5, and then so on we have to go at infinity comma 5, right? Then we will come again with 9, so it will be infinite. Now let's see the point number 4. I think maybe someone is not getting it, so they can just go back in video and you can rewatch this, okay? Because this is very important. When we will start solving the exercises, then you will realize then you should pay attention. So it's better than you start paying attention from now only. Now point number 4, a into b into c equal to a b c such that a b c belongs to a. Here a b c is called an ordered triplet. What it means, if we have a equal to 1 and 2, right? So a into a into a, we have to find out a into a. So first we will find a into a, what will be the order pair. So you can see a into a. So first we will take 1, means we have a equal to 1 2. Now a equal to 1 2, right? So we will take all the order pair with 1. So 1 comma 1, then 1 comma 2, right? Now we will take with this one. Let me just zoom it, comma 2 comma 1 and 2 comma 2, right? So we have find out 1 into 1. Now if we will multiply this with 1 comma 2, so what will be the order pair? So it will be, we have to add 1 in all, then 2 in all. So we have 4, and we will take order pair with this 2, then we will get all the 4 order pairs. So first of all 1 comma 1 and this 1 comma 1, right? Now 1 comma 2, then 1. Now 2 comma 1 comma 1. And if you will focus, you can see then there is no repeated elements here, okay? Now 2 comma 2 comma 1. So now we have taken all the order pair of these all with 1. Now we have to take with 2 comma 1 comma 1 comma 2, then 1 comma 2 comma 2, 1 to 2. Now 2 comma 1 comma 2. Now 2 comma 1. Now we have 2 comma 2 comma 2, right? So we have 1 2 3 4 5 6 7 8 order pairs, right? And this is called triplet, okay? Now we have to move on the examples. So example 1, if x plus 1 comma y plus 2 equal to 3 comma 1, find out the value of x and y. So this is very simple, x plus 1 and y minus 2, and here equal to 3 equal to 1. It means x equal to 3 minus 1. It means x equal to 2, right? And here we have 1. It means y equal to 1 plus 2 equal to y equal to 3. Answer. Okay. Now exercise number 2, example 2. If p equal to, so all the questions are based on whatever we have studied in all these, from the all these notes and this and the Cartesian product, everything, right, in pairs. Okay, so example 2, if p equal to a b c and q equal to r, form a set p into q and q into p. Are these two products equal? So we know that both are the different thing. Here you see a x y and y x both are the different thing, and we will get another coordinates. So let's quickly draw it. So p into q equal to a comma r, b comma r, and c comma r, right? Now we will, so this is the p into q. Now q into p. So we will start with r comma a, then r comma b, then r comma c, right? So both are the different coordinates. Suppose we take, if we will take it with the number 1 2 and 3, and here we have 5. So what we are saying is, suppose 1 2 3 4 and 5, here 1 2 3 4 and 5. So in age a 1 5, so 1 and 5, right? 2 and 5, so 2 and 5. Here we have 3 and 5, so 3 and 5, 4 and, sorry, 3 and 5 only. So we have all the number from this set. Okay, now we have ra. R means 5. R means 5, which is coordinate of x, for example. So 5 1, 5 1, 5 2, 5 3. So this is the different thing, right? Now example 3, let a 1 2 3, b equal to 3 4, and c equal to 4 5 6. Find a into b intersection c. A into b intersection a into c. So this is very simple. Let me just solve one, then you will understand. So let me solve this. I think this is the big one. So what we have to find, a into b union a into c. So first we will solve this one. Okay, so a into b, we have a 1 2 and 3, right, into b. In b we have 3 comma 4. So what we will get here is 1 3 1 3 2 3 and 3 3. Now 1 4 2 4 3 4, right? So this is a into b. Now let's see what is a into c equal to. So a we have 1 2 and 3, right, into c. In c we have 4 5 6, into 4 5 and 6. This is only lengthy, okay, this is not hard. So when we will solve it, we will get 1 4 2 4 3 4. Now 1 5 2 5 and 3 5. Again 1 6 2 6 and 3 6, right, and the comma between all the pairs, right? So what is saying that whatever result you get from a into b and a into c, make a set where all these elements can be seen. Okay, so the element will be a into b union a into c equal to, we will write all the elements, this 1 comma 3 2 comma 3 3 comma 3 1 comma 4 2 comma 4 3 comma 4, right? So we have written 1 4 2 4 3 4, right? 1 5 we have left, 2 5 is also left, 3 5 is left, 1 6 left, 2 6, so 2 6 is also left, and 3 6, right? So we have to write 1 5 covered, 2 5 is not there, so I will write from here because we are out of space there. So 2 5 2 5 comma 3 5 comma 1 6 comma 2 6 comma 3 6, right? So now you can see 2 5 is covered here, 3 5 is covered, 1 6 2 6 3 6 also covered. So this is the answer, right? So the same way you have to do, just find out what is the B intersection C, what is common in B and C. So 4 is only common here, so you have to multiply, like 1 4 2 4 3 4 will be a answer. Now you have to find out what is A into B, then A into C. You have to find out the intersection of that, all the common elements, means not element, common pairs. Now here A into B union C, find out the what is the B union C. In B we have 3 4 and here 4 5 6, so 3 4 5 6 will be there. You have to do multiplication with 1 to 3. It will be lengthy because here we have 3 and here we have 4, so there will be 12 12 pairs, uh, yeah, 12 pairs of sets, right? Now example 4, if P equal to 1 2 from the set, form the set P into P into P. So first we will form the P into P. So what we will get, 1 comma 1 1 comma 2, then 2 comma 1 and 2 comma 2, right? Now we will do P into P into P. So we have already P into P, so 1 comma 1 comma 1, right? Now 1 comma 2 comma 1, now 2 comma 1 comma 1, now 2 comma 2 comma 1. Okay, also we are here we don't have space much, then we will write below this. Now we have written 1 1 1 with, we have paired with 1, okay, 1, and this is completed for all. Now we have to pair with 2 2 2 2, so it will be 1 comma 1 comma 2, now 1 comma 2 comma 2, now 2 comma 1 comma 2, now 2 comma 2 comma 2, right? So this is the answer. You can check or you can try with your own and see whether your answer is matching or not. By the way, all these examples are taken from NCERT book chapter 2, relation and function. If you have any doubt and if there is any contradiction between my answer and yours, you can go and check there, and then you can see then if my answer is wrong or you are doing the in the wrong way. Example 5, if R is a set of all real number, what do the Cartesian product of R into R and R into R into R represents? So what is saying, for example, we have R equal to 1 and 2, suppose, okay. So when we will do R into R, then there will be only two elements of pair, like 1 comma 1 1 comma 2 2 comma 1 and 2 comma 2, right? But if we will do R into R into R, so it will be like 1 comma 1 comma 1, right? 1 comma 1 comma 2 and so on till 8 elements, right? I am not solving that because that is not a point that we want to prove here. What we are going to prove here, that on this, if we have two elements, so then it will be in 2D plane, right? Suppose here x equal to 1 and y equal to 1, so there will be this point on 2D scale. But if we have 1 1 1, then we have to make a third one, okay. So suppose this is x, this is y, and this is z. Okay, I think I can represent this in a better way, or like this, I think. Okay, so now you see on x, suppose 1, and here 2, this will be point here. On z 5, so there will be point here on the 3D dimension. Okay, this was at a 2 dimension, and when we have 3 elements of pair, then the point will be on 3 dimensions, right? Now example C, A into B equal to PQ, PR, MQ, MR. Find A and B. Suppose A equal to, because there is 2 pair of element, suppose we have 1 comma 2, right? And B is also 2 pair, suppose we have 5 comma 7. So if we will do A into B, what we will get? We will get 1 comma 5, then 2 comma 5, right? Then we will get 1 comma 7 and 2 comma 7. There is something to observe here, that 1 2 1 2, the first element of all 4 pairs are belongs to A. Save PDF, just save it quickly. So the first element of all ordered pairs are belongs to A, and the second element of ordered pairs are belongs to the second set. So we can also say here A equal to P and M, P comma M, and B equal to Q R, Q R, so Q comma R, right? So this is the answer. Now we have exercise 2.1. If x by 3 plus 1 comma y minus 2 equal to 3 equal to 5 by 3 1 by 3. So this is very simple. Just take x by 3 plus 1 equal to 5 by 3, right? And y minus 2 by 3 equal to 1 by 3. When we will solve it, we can do 3x plus 3 equal to 5 by 3. Okay, it's in, so if we will solve this, then it will be 3 into x plus 3 equal to 3 into 5, so 3 cross, right? Now x plus 3 equal to 5 means x equal to 2. Okay, when we will bring this 3 here, it will be in minus, so 2 will be the answer. Now here y minus 2 by 3 means 3 y minus 2 equal to 1 by 3. So now we know if we will do the cross here, then this is going to be in product of this, so we can cancel 3 and 3. Now we have 3y minus 2 equal to 1. It means 3y equal to 3. It means y equal to 1. Okay, I hope this answer is correct, because I haven't seen the answer. So if the set A has 3 elements and the set B equal to this, then find the number of element in A into B. So suppose A equal to 3 and B equal to also 3. So A into B equal to P into Q, right? So A into B equal to 3 into 3. It means A into B equal to 9 pairs. So 9 elements will be there. Okay. Now 2.1. If G equal to 7 8 and H equal to this, find G into H and H into G. So this is very simple. I have already explained this in exercise. I hope you will do with your own, and this is the homework. Now exercise 2.1 question 4. State whether each of the following statement are true or false. If the statement is false, rewrites the given statement correctly. Okay, if P equal to Mn and Q equal to Nm, then P into K equal to Mn Nm. P into Q Mn Mn mm. No. If we have two elements here, so the total pair of element will be 4. Okay, I think this would be only like that. Okay, because you see, at P have two elements, right, and Q have also two elements, so total will be the 4 only. What you see, just think for a while and then we can draw the conclusion. Okay, so when for the time you are thinking, let me just move to question number 5. So the question number 5 is saying if a equal to -1 and 1, find a. So we have already seen this also, how to solve this, right? So we have to first find a into a, and whatever we will get the pair, whatever pair we will get, we will also do multiplication with a only, and the final answer will be like this, and this will be in 3 dimensions. When you will do with the 2 only, then you will get in 2 dimensions. When we will do with 3 pair, then you will get in 3 dimensions, right? So I think you have thought of this maybe. So is this a statement is correct or not? Is this statement is correct? If P equal to Mn and Q equal to Nm, then P into Q equal to Mn into Nm, right? P, so we will take the P and then Q, and then we will do the multiplication, so then we will get the all the order pairs. So this is correct, right? If A and B are non-empty set, okay, A and B are non-empty sets, means there is some element, then A into B is a non-empty set of order pair xy such that x belongs to A and y belongs to B. Again, A and B are the non-empty set, right? Then A into B is non-empty set of order pair xy, okay, such that x belongs to A and y belongs to B. So the answer is just write it in comment and then you will see what is the answer. Okay, just write it. So I'll just move on the third one. If A equal to 1 2, B equal to 3 4, then A into B intersection nothing. So what is common between B and nothing? It's nothing only, and when we will multiply this nothing with A, then what will be the answer? So let's see the second one. If A and B are the non-empty set, then A into B is non-empty set of order pair xy such that, so this is true. Yes. And just for your information, this is a wrong statement. Okay, so those who are writing yes in comment, if they have written, so this is a wrong statement. Okay, if we have a pair Mn and Nm, so there will be total 4 pairs. You see, here we have 2 and here we have 2, so there will be total 4, not 2. So this is false. This is a not true statement. Now question number 3. Question number 3. If A equal to 1 2, right? A equal to 1 2 and B equal to 3 4. Then A into B intersection nothing equal to nothing. So let's see. So first of all we have to see B intersection nothing is what. If we will find out what is the common between something and nothing, then it will be nothing only, 0. And when we will multiply 0 with something, it will be 0 only, right? So this is also a true statement, right? I told you that here there will be total 4 elements, right? So just now you can comment that what is the all 4 element, all the 4 possible combinations, right? Now let's move to question number 5. A equal to minus 1 1, find A into 1. You will find with your own, I am not going to solve this. Now A into B equal to AX AY BX BY. Find A and B. So A will be A equal to A comma B and B equal to X comma Y, right? A, B and X, Y. How? We have already seen this above with example. I have solved that. Now question number 7. Let A this, B this, C this and D this. Verify that A into. So in the example we have already covered this. Let A 1 2 B 3 4. Write A into B. How many subset will be A into B have? List them. So I will just tell you, then A have 2 elements and B have 2 elements, so it will be 2 into 2, 4 order pair will be there, right? You have to just later list out, do with your own, how means what are the all the possible outcomes, write it and comment it below, so I can also check whether you are understanding that topic nicely or not. Okay, now question number 9. Let A B be two sets such that number of A equal to 3 and number of B equal to 2. If x1 y2 z1 are in A into B, find A and B where x y and z are distinct element. So this is also very simple. Now question number 10. The Cartesian product A into A has 9 elements, wow, among which are found minus 1 0 and 0 1. Find the set A and remaining element of A into A. So one element is minus 1 and 0, so you can imagine that what will be the other elements. Okay, saying the Cartesian product of A into A has a 9 elements, means if we have A into A equal to 9 elements, what it means? Then we have to do 3 into 3. It means A have a 3 elements, right? Maybe here you can see minus 1 0 is also already given, minus 1 and 0, right? And 0 and 1. So 0 is already here. We have only 3 elements. 1 2 is already written. So what is left behind is 1. So this is A. Okay, remaining elements of A into A. So just do the A into A. It means minus 1 comma 0 comma 1 into minus 1 0 1, and you will get the all the 9 other elements. Okay, so that's it. We have completed the first topic, which is Cartesian product. Okay, in next video we will see what is relation. Okay, that is the chapter about this is the our chapter about what is relation in function. So before starting the relation, we have seen what is Cartesian product, because we are going to use this in this chapter. Now in next video we will see what is relation. Okay, so thank you so much for watching this video, and if you like, you can hit the like button. See you in next video. Bye bye.